Have you ever watched an ice cube float lazy on top of your drink, calm, effortless, almost magical? We see it every day in our water bottles, in lakes, in the frozen poles of our planet, and yet, hidden inside that floating cube lies one of the most extraordinary secrets of nature. If ice didn't float, if it sank instead, the world as we know it would not exist. Our oceans would be dead, our climate would collapse, life might never have evolved at all. So, how can something solid, something frozen, be lighter than the liquid it came from? Today, we are diving deep into one of scientists' more beautiful paradox, the mystery of floating ice. Number one, the law that water breaks. Most substances follow a simple rule of nature. When they cool, they shrink. Metals, rocks, oils. As temperature drops, molecules slow down and come closer together. They become denser, heavier per unit of volume. So by this rule, frozen water should sink, but when you pour ice into water, the opposite happens, it floats. What is going on? To find the answer, we must journey into the microscopic world where atoms dance, twist, and bond in ways that defy intuition. Inside the molecules, water as we know is H2O, two hydrogen atoms and one oxygen atom. But this tiny molecule has an extraordinary shape. It is not a straight line, it is bent like a boomerang with an angle of about 104.5 degree. Because of this shape, the molecules becomes polar. Oxygen pulls electrons towards itself, making that side slightly negative, while hydrogen becomes slightly positive. This polarity is what gives water its hydrogen bonds. A weak attraction between the positive hydrogen of one molecule and the negative oxygen of another. When water is liquid, these bonds form and break rapidly, billions of times per second. But when temperature drops and molecules slows down, they start to lock into place, and this is where the magic begins. Point number 3, the birth of the ice crystal. As water freezes, each molecule connects to 4 others in a perfect hexagonal lattice, a beautiful open framework with empty spaces between molecules. This pattern pushes them slightly apart, making ice occupy more volume than liquid water. That means less density, and less density means ice floats. This is one of the rarest properties in the natural world. In fact, almost no other substance behaves like this. Liquid water reaches its maximum density at 4 degrees Celsius, not at freezing point. Below that, it begins to expand, setting the stage for ice to rise to the surface. Understanding density, let us simplify the concept. As we know that density is equal to mass per unit volume. If two objects have the same mass but one takes up more space, the one with greater volume is less dense. Liquid water 1 gram per centimeter cube, ice 0.92 gram per centimeter cube. That 8% difference may look small, but it is enough to make the difference between a living planet and a frozen wasteland. The planetary consequences. Now let us imagine an alternate Earth, one where ice sinks instead of floating. The first winter arrives, water on the surface freezes and sinks, more water rises, freezes, and sinks again. Layer by layer, lakes and oceans solidify from bottom to top until every body of water is frozen solid. No fish, no plants, no plankton, and no way for the sun to thaw the ice, because sunlight can only heat the surface. Our planet's ocean would become vast blocks of ice, reflecting sunlight back into space, cooling Earth even more. Eventually, the whole world would freeze over a snowball Earth. So yes, the reason you can sail across an ocean is because ice floats. Floating ice and the survival of life. When ice forms on the surface of lakes and oceans, it creates an insulating layer. That layer taps heat underneath, keeping the water below at a stable 4 degrees Celsius, the temperature where liquid water is densest. This means fish and aquatic plants can survive even in the coldest winters. In fact, entire ecosystem beneath the ice depend on this delicate balance. And every spring, when the ice melts, it stirs up nutrients Recycling oxygen and minerals is essential for life. This process helps drive Earth's biological rhythm from algae blooms to migration patterns. The hidden role in climate. Floating ice does not just protect life, it regulates the planet's temperature. Glaciers and polar ice caps reflect sunlight through the Albedo effect, cooling Earth. As global warming melts more ice, less sunlight is reflected, causing even faster warming, a dangerous feedback loop. In a sense, the floating ice acts as Earth's natural thermostat, a shining mirror that keeps our climate in check. Without it, the balance between ocean and atmosphere would collapse. Beyond Earth, the cosmic perspective. Water behaves this way not just on Earth. Scientists have found frozen lakes on Mars, icy moons like Europa, and Enceladus. And beneath these frozen shells, liquid oceans may exist. Those oceans could harbor life just like Earth's. And once again, it all depends on this one incredible property: ice floats, the beauty in the ordinary. So next time you hear the clink of ice in a glass, remember it is not just frozen water. It is the echo of billions of years of molecules perfection, a miracle written in the language of physics and chemistry, a silent guardian of life itself, something so ordinary yet so essential that it shapes the density of planets. From your kitchen to the frozen poles, from Earth's oceans to distant moons, the reason ice floats connects every corner of the universe. So the next time you drop an ice cube into your drink, take a moment to appreciate this delicate invisible balance, the one that lets our world breathe, live, and thrive. If you loved this journey into the hidden science of everyday life, hit like, share this video with your curious friends, and subscribe for more wonder of nature explained in depth. Because in the world of science, even the simplest things hold the greatest mysteries.